Welcome back to day 3 of our graphing quadratics unit. Our goal for today, given a quadratic function that models a real-world situation, you will be able to describe the path of the parabola in context of the situation. So today we're going to take a look at different real-world examples, such as a fish jumping out of the water that creates that parabola shape. All right, so let's jump right into our day 3 notes for exploring quadratics. Make sure you've got your calculator handy. All right, so let's take a look at number 1. So Xavier throws a ball which follows the path of the function f of t equals, and here's our function, where t is the time in seconds that the ball is in the air, and f of t is the height of the ball in inches. So for this situation, here we go. Here's Xavier. He's going to throw a ball in the air, and it's going to come back down and hit the ground. So here's the ground. So this is the parabola that we want to graph. All right, so let's go ahead and let's give this a try. So here is our equation. So remember, the first thing we always have to do when graphing a parabola is we have to figure out what our a, our b, and our c values are. So here, our a value, the number in front of the x squared, or in this case it's t squared, is negative 4.9. Our b value is 19.6, and our c value is 58.8. Okay, so now before we can graph a parabola, we always have to find the middle of the parabola, and we do that by using our axis of symmetry. X equals negative b all over 2 times a. So let's go ahead and fill it in. So here we're going to get negative 19.6 over 2 times negative 4.9. Okay, so that gives us negative 19.6 all over. So let's go ahead. 2 times negative 4.9 gives us negative 9.8. And then when we divide those, we end up getting 2. So x equals 2. So this is the middle of my table of values. So let's go ahead and write out our table of values. Okay, but this time let's add a little bit extra here. Up here they told us, well, here we're going to use t, which is really our x value, because instead of x they use t in the equation. So t is time, which is in seconds. Okay, and y represents the height, okay, which they told us is in inches. Okay, so let's go ahead. We know x is equal to 2, and that's our axis of symmetry, so that's going to go in the middle. So this is our turning point. So what we want to do now is we want to pick 4 values below and 4 values above. So I'm going to go negative 2, 1, 0, negative 1, negative 2, and 2, 3, 4, 5, and 6. Now I'm going to plug it in, and then I'm going to go to my table of values. And as you can see, we're getting decimals, and that's okay. This is a real-world example, which means we may have decimals, and I want to start my table at negative 2. So at negative 2, I see we're at 0, and then 34.3, 58.8, 73.5, 78.4, 3 is back down to 73.5, and I'm going to follow the same numbers all the way back down. 4.3, and let's just double check. When we get down to 6, yep, we're right back down at 0. Okay, so now to graph this, because part A was to graph, if I look over here, here's my x and my y. Now, my x's, I can definitely still count by ones, but my y values, my height in inches, well, it's going to go higher than 10, which means we're going to have to count by more than just 1. So here we're going to have to count by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. All right, and then we're still going to count by ones on our x-axis. Okay, so let's go ahead. I'm going to have you pause the video and plot all of your points. All right, let's go ahead and take a look. Did you plot your parabola? So it goes up, and then it goes back down. Okay, so now let's talk a little bit about the fact that this is telling a story. So here, Xavier is throwing a ball. Okay, so if he's throwing a ball, well, let's think. Can our ball go below the ground? So here, this is where our height is 0. So this is like it's the ground. Can our height go below the ground, or once it hits the ground, does it stop? It stops. So that means we cannot use this part, nor can we use this part. So those are actually going to go away. We can't use them. Now also, x is time. Now if x is time, can you have negative seconds for time? No. So that means our time has to start at 0, which means we're not going to use this part of the parabola either. So the only part of the parabola we're using is this part right here. Now doesn't that look like the picture we drew at the very beginning of Xavier? Because he starts at his height, it goes up, and then it goes down. So our ball is going up, and then it goes down. So now we have just one part of the parabola that goes with our story. Okay, so let's talk a little bit and let's analyze this. Let's explore the picture here. So what is the highest height that Xavier throws the ball? Well, the highest height is going to be right here. This is our maximum. And let's take a look. So let's go to our table of values. Our maximum, what's the highest height? It is 78.4. Now remember, the height was in inches. Okay, now let's take a look at question C. At what time does the ball reach the ground? So remember, time, that's our x-axis. So what time did the ball hit the ground? It hit the ground at 6 seconds. Which means, part D, how many seconds was the ball actually in the air? Well, from time 0, time 1 second, 2 second, 3 second, 4 second, 5 second, it was in the air for 6 seconds. Okay, now this next one, this is a big one. During what domain interval was the ball increasing? Remember, domain is your x values. So let's look at the picture. So in our parabola, so here is where our ball is going up, 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 up. When it hits our maximum right here, this is the turning point. So there it stops going up and it starts going down all the way till it hits the ground. So this is the part where we are increasing, and this is the part where we are decreasing. So during what domain is the ball increasing? Well, the domain is your x's, so it starts at 0 and it increases until it hits 2 seconds. So what is the interval where the ball is increasing? From 0 to 2 seconds. During what domain is the ball decreasing? So let's go back. So the ball is decreasing, so it starts here at the top at 2 seconds and it decreases it until it hits the ground at 6 seconds. So here it would be from 2 to 6 seconds. So ladies and gentlemen, this is what we call exploring our parabolas. We're exploring the quadratic function in terms of the situation that it is modeling. All right, let's flip over and let's try one more. Okay, so here we have Abigail tosses a coin off the bridge into the stream below. The distance in feet the coin is above the water is modeled by the situation here, where x represents the time in seconds. We want to graph the path of the point. So again, here we have Abigail. She's throwing a coin up and it's going down off the bridge until it hits the water. So we want to graph that in our parabola. So once again, we're talking about a real world situation. So instead of graphing all of the points, let's think. If x represents time, can we have negative time? No, we cannot. So let's go ahead and let's start this out. X and y. X is going to be our time. Y is going to be our height. And this time, instead of finding the axis of symmetry, I know my time has to start at 0. So I'm just going to go 0, and I'm going to put a bunch of numbers. So let's go ahead and put 8 numbers down. All right, now let's go ahead to our calculators. And let's go back to your y equals, and let's type this one in. So negative 16x squared plus 96x plus 112. Go to my table of values. And now let's go ahead and fill it in. Okay, and I'm going to go down. Oh, 7 is 0. Now, at 0, that's where it hits the bottom, so I don't even have to use 8 here. All right, so at this point, we have to go ahead and graph. So I have to start at 0. Now my axis is going to be time. It's pretty easy to see. We can count just by ones here. 3, 4, 5, 6, 7. But our x's, we have to get all the way up to 256, and there's not many spots here. Okay, I already counted. There's not enough to count by 10s. So instead of counting by 10s, let's go ahead and count by 20s. So 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260, and that's as high as I have to go. Okay, so this is my time, and this is my height. All right, so let's go ahead and plot these points. So at time 0, you're already starting at 112, which is going to be about here. At 1, we're at 192. Then we go all the way up at time 2, we're at 240. At 3 seconds, we're at 256. Back down to 240. And back down. Okay, so let's go ahead, draw the path of this coin. It goes up pretty high, and then it goes back down. We've got it. All right, now we're going to answer a couple follow-up questions. So part B, what is the greatest height of the coin? So how high did we get? So let's take a look. The highest height, it looks like it's right here at 3 seconds, 256. And up here they told us the height was in feet. So 256 feet. Okay, part C, how much time will it take for the coin to hit the water? So look carefully. Where do we hit the bottom? Where do we hit the water? It goes up, it goes down, and it hits at 7 seconds. How tall is the bridge? Let's go back and reread here. So bridge, where is the bridge here? So Abigail tosses a coin off the bridge into the street. Oh, so here's the bridge. The bridge is where you're starting. So where did we start? At time 0, how high was Abigail in the air? She was at 112 feet. So the bridge has to be 112 feet tall because that's where she started. Okay, what is the domain for the path of the coin? So remember, your domain is your x values. So where's our smallest x value? It's at 0. What's our tallest x value? What's our biggest x value? It's 7. So we start at 0, we go all the way to 7. So 0 to 7 seconds. Okay, what is the range? Remember, range is your y values. Okay, so let's take a look. What's your smallest y value? Well, here our smallest y value is 0. And what's your tallest y value? 256. So from 0 all the way to 256. So from 0 to 256, and this is going to be in feet. Okay, part G, what is the interval in which the coin is increasing? So let's take a look here. I'm going to go ahead, this is my vertex, this is my turning point, which means Abigail is tossing the coin. It goes up, 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 and then it stops there, and here it starts going down, 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 down until it hits the water. So increasing, it goes up, decreasing, it goes back down. So for increasing, we're going up for 3 seconds. So from 0 to 3, it is increasing, and then from 3 to 7, it is decreasing. All right, ladies and gentlemen, I know this can be a little confusing, but do your best, and I'll see you in class.